How to evaluate expressions while debugging with GDB. Have you ever found yourself stuck trying to figure out what a variable holds while debugging your code? If so, you are not alone. Evaluating expressions can be a game changer when using the GNU Debugger, commonly known as GDB. This tool allows you to inspect values, compute expressions, and even call functions while your program runs. Let's break down how to make the most of this feature. When you want to evaluate an expression in GDB, the command you will use is print. This command is often abbreviated as P, for example. If you want to see the value of a variable named x, you simply type px. This will display the current value of x right in your terminal. But it doesn't stop there. You can also evaluate more complex expressions. For instance, if you want to add two variables together, you can type pxy. If you need to call a function like checking the length of a string, you would type pstrlen, str. You can even assign a new value to a variable while debugging by using px is equal to 5. One handy feature of GDB is that it stores the results of your evaluated expressions in special convenience variables. These are labeled as $1, $2, and so on. After you evaluate an expression, you can reuse these results in future commands. For example, if you type p2 plus 2, GDB will return $1 is equal to 4. You can then use this result in another expression, like p1 asterisk 2, to multiply it by another number. If you are curious about the data type of a variable, GDB has a command for that too. You can use whatis followed by the variable name, like whatisx, to see its type. This can help you avoid errors related to data types. When you hit a breakpoint or step through your code, evaluating expressions becomes crucial. You can check the state of your variables or test changes without restarting your program. This makes it easier to verify your assumptions or test potential fixes. For those who want to dig a little deeper, GDB also has the X command, which allows you to examine memory at specific addresses. However, for evaluating expressions in your programming language, print is your go-to command. GDB also supports scope resolution, which is particularly useful in programs written in C++. This means you can inspect variables or functions in different namespaces or classes. To make your debugging process smoother, here are some practical tips. Use the print command to check variable values at breakpoints. Remember to utilize the saved results like $1 and $2 to build on previous evaluations. Use whatis to confirm variable types, which can help you avoid type-related issues. You can also modify variable values on the fly by assigning new values in your print commands. Lastly, consider combining expression evaluation with conditional breakpoints to stop execution only when certain conditions are met. By mastering expression evaluation in GDB, you can dynamically inspect your program state. This interactive approach makes identifying and fixing bugs much more efficient.